Okay, hello. I'm Dr. Evie Kendall, and I have the privilege of moderating this panel with a number of experts in the field of environment. So first, I'd like to echo Thomas's statement and acknowledge the traditional owners of the land on which we are gathered in recognition of their continued custodianship of the land, water, sky, and space, showing respect for their elders past, present, and emerging. So partly it's in recognition of our Indigenous heritage in this country that we want to try and be very inclusive with our language for the panel. So we will attempt to increase our use of terms like establishing a base on the moon rather than colony, and exploring rather than colonising. So we will try to, as I said, increase the more neutral terms and decrease some of the more charged terms there. Also, Giuseppe said that the Moon Village Association is all about inclusivity. So again, with that in mind, we try to increase more neutral terms that focus on humanity rather than terms like manned spacecraft that seems to exclude most of what we have here. So, just to give you a little bit of information about how the panel will work, each of our speakers is going to give a short presentation about their area of expertise, and then we're going to open up for questions. So again, lovely friendly discussion is what we're looking for, and we invite the audience to really engage with us here. So, I'm going to give the names and the affiliations of each of our experts just first, and then I'll let them introduce themselves in detail, and then we'll start our presentation. So first, we have Dr. Yasmina Lazendich-Galloway from Monash University. Please introduce yourself.
They're on, sorry. So yes, I'm a person with a very long name, so my students tend to call me Dr. J. I'm an astronomer. I started as astrophysicist, then became astrochemist, then high energy astrophysicist, then astrobiologist, and now I'm just everything to do with space. Because space is amazing, and most importantly, the reason I like it is because I like how space motivates us to make technology, to make breakthroughs that then get to be used on Earth, and I'll talk about a little bit that in my talk.
Fantastic. Now I'm going to introduce the next speaker in order, so that's Dr. Helen Brand from Australia's synchrotron.
Hi. So I work at the Australian synchrotron as a beamline scientist. So I trained as a planetary geologist in London, and my research is looking at the stuff that various planets and moons are made of, and how do they behave if you put them in the temperature and pressure and magnetic field and electric field and anything else you can think of to do to a rock. If you do that to it at the conditions you find on other planets, how does it react? How does its structure change, and what are the implications of that on geological landforms that we might see on those planets?
Excellent. Next, Dr. Alice Gorman from Flinders University.
Thank you. So I'm an archaeologist, and I focus my research on objects and places in space. So from the surface of the Earth, launch sites, antennas, to space junk in Earth orbit, to planetary landing sites, particularly on the Moon and Venus, which is my other passion. I'm also a director on the board of the Space Industry Association. So if you want an example of how inclusive space can be, I'm an actual archaeologist involved in supporting the growth of space industry in Australia.
Fantastic.
And she has the coolest handle, Dr. Space Junk.
At
Yes,
Dr. Space Junk. Love it. Okay, and finally we have Cara Wiseman from the Office of the Victorian Government Architect.
So I am not an amazing space scientist, but what I am really interested in is how we shape the places where humans live now. And so there's probably a lot of lessons we can take from that into how we think about how we live in other places and shape them. Yeah.
Excellent, fantastic. And I've already introduced myself, but I'm Evie Kendall, and my recent research has been on space ethics. So at this point, I'm going to hand over to Yasmina to start us off. That's our clicker. It should work just from there.
Oh, I can. Oh, brilliant. Okay. I thought I'll have to stand behind Langton's, and we kind of banned lectures in Monash. So yes. So I'm with the School of Physics and Astronomy at Monash, and I teach mostly first-year astronomy and astrobiology courses. And I also run a very popular MOOC, How to Survive on Mars, Science Behind Space Exploration. Yes, and we teach people how to grow potato in their own products. So where my interest is, by the way, you have to compost them, you can't just put them there. But yes, you have to watch the MOOC to find out. So where my interest in planetary science is basically my research is supernova remnants, which are these remnants of massive stars that explode, but they are the ones who create elements. You know the saying, we are stardust, so that's where elements come. And those elements then also build habitable planets, and they build resources that we can use in other planets like Mars and Moon to help us spread our wings across the solar system and then galaxy, hopefully one day. So as astronomer, what we like about Moon is that, well, number one, it gave us first measurement of time. So one of the oldest time-keeping tool was the Moon, hence we have the month, which is the time that Moon takes to go through its phases. So it was the oldest scientific object for studies for ancient tribes and civilizations. We have unique Moon in respect to other solar system bodies, that it's the largest in respect to our planet. It's not the largest moon in the solar system, but when you compare it to the size of Earth, it is quite large. And that's important because when you form planets from protoplanetary disk at the time the stars are formed, they can wobble. And that wobble sort of makes them go like this across the plane. It means they reach sunlight at a different rate. And that means very unstable climate. So the Moon stabilizes that climate, which means it have aided rise of life on Earth very likely. It also, because it's so big, it causes tides. And again, we think that having sort of salty water spreading over rocks and coming back with tides have managed to make some of those amino acids that we know have caused life. And also another thing, it's important that it's quite big and shields of impact. So we know that at a very early time of formation, we had a lot of big rocks bombarding Earth, but Moon was there to protect us and still protecting us today. NASA actually has a live camera that you can see from time to time. You can see a flash on the dark side of the Moon, and that's actually a big meteorite hitting it. So important thing about Moon is when Galileo looked at it 400 years ago, first time with the telescope, and showed that it's imperfect, it basically started changing the idea that heavens are permanent and perfect and something that never changes. So what I like about Moon, and this is from a history of science subject that I started teaching in our Italy campus from last year, because I realized the way we teach science is very old-fashioned. We teach it as a set of equations and concepts to know and problems to solve, but not about ideas, how ideas emerge. And so if we really want to make a big leap, if we really want to fix all the problems we have, we can't just throw money in and still use the same ideas. We have to teach our young people how ideas came about. We have to inspire them. You might have heard a sort of talk that it's difficult to teach creativity. Well, it's not really. If you mimic creativity first, at some point you'll understand what it is. So I started teaching a history of science, and of course it started with Galileo in Tuscany, because this is the age where a scientist like him learned to negotiate with government and powers to be in order to push ideas through. And he paid the price, but luckily it wasn't ultimate price. But nevertheless, it was a very good example of how scientists have to work today as well. So then we have Earthrise, which is a first picture that was sent to us from the Moon. And again, it's just amazing to look at. So when I ask sometimes students at exam, what's important of having a large moon? There was a lovely answer one year. It gives astronomers something nice to look at. So that's true, but also when you look Earth from Moon, you do realize how fragile Earth is. You do realize how we are all just one nation, and we shouldn't fight, we should collaborate. So it's actually that photo that gave rise to environmental movement, and we're part of the environmental panel now. So I'm very inspired by a song about 20 years since the first landing on the moon, a young poet in America, well, singer in America, written a song, and I'll ask Evie to deliver it.
Not to sing it, you'll be happy to know. Okay.
The song is Sleeping Satellite by Tasmin Archer, so this is the first.
Excellent. First stanza. Did we fly to the moon too soon? Did we squander the chance in the rush of the race? The reason we chase is lost in romance, and still we try to justify the waste for a taste of man's greatest adventure.
So this verse is so lovely that we were all inspired and we expected more, and then we lost it. Of course, we know that moon landing came because of moon race, and Alice is going to talk a bit more about that. But it was start of something great, and then it fizzled away. So this is a reminder. I mean, this is a young 19-year-old singer who's wondering 20 years after why we don't have space colonies, why we don't have space settlements, space bases. Sorry, so easy to fall in that language. But it's something that we still ask. This is from 1989 song, and this is 30 years later, and we're still asking the same question. So we should not ask anymore, we should be doing. Next verse.
I blame you for the moonlit sky and the dream that died with the eagle's flights. I blame you for the moonlit nights when I wonder why are the seas still dry. Don't blame this sleeping satellite.
So Eagle's flights refers to the modules, that's how they were called in Mercury and Apollo program. And she refers to the seas still dry, which is mare at the moon, which is basically sort of craters where we could have imagined if humans have established a base, we could have actually had a pool on the moon in the crater. How awesome would that be? And of course, she's realizing, you know, she shouldn't be crossed at the moon, so we shouldn't blame Moon for it. And just one more.
And when we shoot for the stars, what a giant step. Have we got what it takes to carry the weight of this concept? Or pass it by like a shot in the dark, miss the mark with a sense of adventure?
So this is a great question she poses, is after we have lost the first race, because it is lost now, it has lasted and then nobody really won at the end, because it fizzled away, are we actually able to do it for a bigger cause? Are we able to do it not just to prove that we are the best nation, or strongest nation, or most capable nation, but are we able to do it for all the humankind? So this song inspires me all the time. I have it on a wall of my office, and when I teach my students importance of any research, especially astronomy, that seems so unapplicable to our earthly problems, I show them that actually all that research does find a way back. The most famous example is, of course, Wi-Fi that we all use now. I can't live without it. And some of us are born at the time when they were very dark and boring time when there was no Wi-Fi, and we know how horrible that was. Just joking. But that comes from an algorithm that was searching for black holes. So nobody ever thought, you know, they were just interested in searching black holes. So how can maybe something to do with the moon help us? Well, European Space Agency have tested a 3D building by using a moon analog material and a 6 by 6 meter 3D printer. Can you print a brick to create a base on the moon? Because you're not going to be bringing all the equipment with you. And they're very successful. And so, not linked to that was an architect in US who worked in poor communities in Mexico to help build housing. And he realized that if he mixes cement with dirt, which you have to dig out to make a house, you can build a house and apply some of the 3D printing. You can build a house in a month. And the beauty of it, it requires very little maintenance, unlike brick houses or wooden houses, and has very low imprint. So again, if we develop technology and mindset to build some cool space houses, maybe then we actually start building cool space houses on Earth as well. And at the moment we have U2 rover, which is U2 rover 2, second rover from Chinese Space Agency, which has landed on 3rd of January, and it's working very hard to figure out what kind of materials we can exploit from the moon, in a good sense, not in a bad sense, exploiting, but what we can use, and one of them is helium-3, which can give us clean energy. So a lot of these space exploration actually does find use on Earth. Thank you very much.
Thank you.
Oh my God, this is the first talk I finished right on time.
0.0. Excellent. Thank you so much, Yasmina. So next we have Helen. Can you see the screen and timer from there? Yep. Fantastic. Thank you very much.
I'm not promising to finish early or late. We're just going to see how it goes. So, what happens if I click one of these? Anything?
Okay. Sorry, can we have Helen's presentation up?
Oh, there we go.
Yep.
So, I am from the Australian synchrone, and I like to squash rocks and heat rocks and cool them down, as I said before. And I first came to planetary geology because I had absolutely no idea what I wanted to do. And I liked rocks, and I liked astrophysics. And I think probably that's how quite a lot of people come to planetary geology. And the beautiful thing about planetary geology is we get to use all of the spacecraft images for our mapping. Now, if you're a hardcore geologist, you say, but you don't get to go in the field and look at rocks, which is not quite true. But we get to make our maps from all the beautiful spacecraft images, and it really is an art to being able to look at a flat image and work out layers and work out how those layers have changed through geological time, and then infer the processes that have made them. So I'm going to very briefly start by talking about the formation of the moon, and I apologize for the pixels in this picture. Being a planetary geologist who deals with spacecraft images, you become a pixel Nazi. And there are too many pixels in this picture. It does not have high enough resolution. I apologize. But so 4.5 billion years ago-ish, I'm going to say ish, this happened to the proto-Earth. So we had a huge impactor, about the size of Mars, coming in, impacting with early Earth. So at this point, early Earth had started to differentiate. So you start in the protosolar disk, you get all of the stuff comes together at that point where the Earth's orbit will eventually be, and it's starting to coalesce, and it's all kind of coming together. And then once it's kind of done that a bit, it starts to go, ooh, I'm going to settle by gravity because it's just too hard to sort of not. So all the heavy stuff goes to the middle, and all the lighter stuff goes to the outside. And then in comes our impactor and impacts, and some of the material gets thrown out, and that's eventually going to become the moon, and then the rest of it sort of coalesces to be the Earth as we know it today. And so the stuff that you get that's in the moon, consequently, has slightly different elemental compositions to the remaining bits of Earth. So you get more of those lighter elements that have gone to the moon and more of the heavier elements on Earth. Oh, I went the wrong way. Always happens. So if we look at a picture of the moon, and I intend to stay on this slide for as long as I can because it's a planetary image and I like planetary images. So we can see, we see two main rock types. You don't have to be a planetary geologist to look at the moon and see two main landscapes. You see the dark maria and you see the lighter, brighter highlands. There is much more to the story than that for the composition of the surface and the sort of features that we see, but the dominant process that we see on the moon today and throughout its history is impact craters. You see these bright ejecta around the craters, and I would love to have a pointer to show you, but you can see the bright ejecta around them. And then in the mare, you see this dark, much darker basaltic surface from lava flows. Oh, wrong way again, every time. So we'll talk about the lunar highlands first. So if anybody's been to the Yuyangs on a walk and you've walked up those mountains, you will have seen large white crystals like these ones that you can see in the picture. These ones are actually from Cornwall. These are plagioclase crystals, and they make up 80 to 90% of the lunar highland rocks. They have calcium, they have aluminium, they have silica. The sort of landscapes that we see, the landforms rather that we see in the lunar highlands, you get the heavily cratered areas, so you're going to get large differences in elevation from the basin floors up to the mountains. So if we're going to think about going to the moon, we need to think about how we're going to navigate these differences in landforms, and are there going to be sort of trials associated with getting all your stuff to where you want it to be. Now, if we look at I'm going to do it wrong again, aren't I? Yep. Every time. It's this one. Let's do that way around. So if we look at the Maria, there's often a misconception that the Maria are younger because they look like they're less heavily cratered. They're actually not. They're slightly younger, but they are not that much less cratered. There's not that much difference in the ages of the surfaces. And so we think these are basaltic lava that's flooded impact basins. And you can kind of see this in this picture where it kind of looks like the edge of a shoreline and the lava's kind of run up to its level like water would in a sea. And there's two types, and they have different elements in them, different materials. So one of them has lots more titanium and one of them has less titanium. So titanium could be quite a useful resource for us on the moon because you can sort of alloy it with various things to make some good materials for building, for if you're going to do in situ resource utilization, which is dig it up and use it where you find it, or near to where you find it. We could do some processing there that could be quite useful. So in addition to the Maria being lava flows, there are also some evidence of little volcanoes, which had fire fountains. So they were probably a bit more like the Hawaiian eruptions that sort of spew out little fountains of lava as well as their big flows. And those are quite interesting because they tend to trap volatile materials. So some of the things like, sulfur volatiles, carbon dioxide, carbon monoxide, those sort of things can be trapped in those beads, and you can also get different elements in those as well. And the glass beads that those produce are actually quite a useful resource because they're easy to process compared to the lava flows that are sort of big and blocky and difficult to process by normal methods. So those might actually be quite interesting places to put bases if we were going to. So one of the biggest resource sinks, I don't know, we could call it, is the lunar regolith. So this is the lunar soil. So the top 30 centimeters of this are very powdery, and you can kind of see that from the boot prints left behind by astronauts. And then below that, it gets very compacted. But you can trap a lot of things from the solar wind. So as the solar wind comes in and interacts with the surface, it kind of goes into the regolith, and you can trap things there. And then as it gets compacted, it gets more and more trapped. And that's where the helium-3 resources are thought to be in the lunar regolith. So the lunar regolith could be very important for getting a lot of different resources out, and then maybe also using it as a building material. Because it's quite easily compacted, and again, ESA's been doing these trials with the 3D printing. So I've just started a project with ESA using the same regolith material where we're simulating impacts into the regolith material using a light gas gun, which is very exciting. And it basically means I get to fire a little shot of something at like 7 meters a second. It's far too exciting. And then we're going to bring those craters, those example lunar craters done in different conditions, we're going to bring them over here to the synchrotron, and we're going to do large volume computer tomography of them. So just like you have in a hospital, but we can do sort of this size by this size by this size blocks. They did a rhino head last week because they're trying to build prosthetics for rhinos, but I digress. So we're going to bring those back over here, and we're going to scan them so they can see the structures that form with different compacting of the regolith. They're going to see how that affects the strength of the material, how cracks form, if you get different structures when you do different speeds, different sizes, different compactions of the regolith. So we're going to be doing that to see if we can use it in a useful way. So kind of just as a finish, I wanted to put together some of the potential resources I think that we can find on the moon. And I'm happy to talk about or how easy it would be to extract each of these from their various places on the moon, and whether it's economically viable to do so, because some of these are going to take a lot of energy to do so, and there becomes a point when is it worth it? And for some it is, and for some it isn't, and that's the sort of thing we need to be thinking about, and we need to start working out if we're going to think about putting our bases on the moon and using the things that are there. So this was more for the questions later, potentially. And one quick one of where is the water on the moon? It's at the poles. It's in shadowed craters. That's pretty much all I'll say on it. And my time's up.
Look at that.
No, one more.
Oh, okay.
One more
Okay.
of where we could live on the moon. Lava tubes. Because I love lava tubes. They're really cool. There is a lava tube that you can go to. I think it's out near Organ Pipes National Park somewhere. But there are lava tubes on the plains west of Melbourne. And they are what you would think they are. They are tubes where lava goes through, and then the lava's gone, so there's a hole left. And so these can provide us with potential habitat sites. They're underground, they're going to be stable in temperature, and they're going to protect the astronauts and their equipment from solar wind, any other nasty particles, radiation, micrometeorites, anything else like that. So I think we should go and live in those. And I'll stop.
Excellent. Please thank Helen. I thought you got competitive and finished dead on the 0.0 to beat Yasmina. Okay, so next we have Alice. So we'll just wait for your slides to come up, and then there we go. Thank you.
Thank you. Oh, I'll find out. So I'm going to talk a bit about the cultural environment of the moon and human cultural heritage on the moon. So just as a very quick snapshot, what we have is now a lunar landscape, including the far side, which is littered with the artifacts of human engagement with the moon. So you can see on that image, the yellow sites are the Apollo crewed landing sites, the green ones are the USSR lunar robotic landers, and the pale blue or grey are the US Surveyor landers. And you can see the numbers of some of them in the site. So this is not everything that's on the moon, it's just a little tiny sample, a large sample of human missions that have gone to the moon. And we also have some satellites currently in orbit and satellites that have crashed on the surface. So this is quite a rich cultural landscape. And some people say, you know, this is terrible. We've gone to the moon and left trash there. Well, kind of yes, but also kind of no. This is heritage. This is cultural heritage of the space age, which you can define basically as things from the past that are important to preserve for future generations, based on how we feel about them, based on our emotional attachments. Okay? So I'm going to take just one quick example of a site that's very topical this year. It's the 50th anniversary of the landing of the Apollo 11 mission. And this is possibly the most interesting heritage and archaeological site on the moon. So from a heritage perspective, this is how we might look at this place. We could say it has incredible historic heritage as that location where humans literally in their own bodies stepped into the soil of another world. It's the height of the Cold War, a very particular period, which, as Jasmina mentioned, left a huge imprint on the way we engage with space and how we look at space. This site has aesthetic significance. By that, I don't mean whether it's beautiful or ugly. I just mean it has a very distinct feeling. It has light and shadows and colours that are not of this world. It's a place where we can study how humans interacted with this completely other world with 1/6 Earth gravity. All of those footprints actually show how human bodies adapted and operated within that environment. And we can study them to find out stuff we didn't know about how we moved on the moon. The social significance of this site is that people remember it. They remember where they were when they saw the Apollo 11 moon landing. 600 million people across the world, the largest television audience ever at that time. And people have strong beliefs about this place. Some of them are conspiracy theories, but they're still strong beliefs. Others see this site as an incredible symbol of human technology, human aspirations and endeavour. So this is a site with a lot of cultural significance. These places are far away. Nobody is out there at the moment destroying them, but this situation is likely to change. So as well as Apollo 11, we have all of those other places and more that we mentioned, which represent the history and heritage of our engagement with space. They're very exposed, no atmosphere on the moon, stuff coming in all the time, some of which we've heard about already. So these materials are going to deteriorate over time, and we can't do much about that. What we can do something about is future human activities which are going to adversely impact on the ability of these places to survive. So many people are planning to go back to the moon. Where they choose to site their bases or their industrial installations or their mining operations could have a huge impact on the ability of something like the Apollo 11 site to actually physically survive for those future generations. So where things are located is going to be critical. Once more people are on the moon or more robots are on the moon, then the density of visitation to sites like Apollo 11 is going to have an impact on the condition of those materials. And we know what happens on Earth with heritage sites. People go to them, they loot artifacts from them to sell on the antiquities market, and I'm sure most of you know there is an incredibly vigorous collecting and trade market for things that have been in space. And people want to do this. They want to steal stuff from these sites and sell it for profit. We know vandalism is likely to occur. We know that people will, with the best of intentions, just want to go and take a little piece of one of these sites. So that's all stuff maybe we can do something about. But the primary threat is actually when more vehicles are landing on the moon, they're going to stir up the dust that Helen mentioned. This dust is sticky, it's abrasive, and it's very damaging not just to heritage sites, but to the operations of any kind of human installation or building. We know this dust is a problem because it was flagged as something before the first Apollo missions went, and they studied the dust intensely. But in 1969, quite an extraordinary event happened. Some people call it the first archaeology on the moon. So Apollo 12 landed just 180 meters away from Surveyor 3, which had landed on the moon in 1967. So in that picture, you can see Apollo 12 right in the background, and that's Alan Bean, who went to Surveyor 3, and he removed a camera and a couple of other pieces, and he took them back to Earth. When they were analysed, it was found that the surfaces facing the Apollo 12 landing site had been heavily abraded and pitted. This is the impact that stirring up lunar dust can have. We know even more about the impacts of dust because an Australian space scientist, Professor Brian O'Brien, designed the first dust detector experiment for the moon. It was sent to the moon on Apollo 11, and he's been gathering and analysing data about this for quite some time now. So we have a problem on the moon. It is the impacts of dust on human materials. If we are going to have bases of any kind or industrial or mining operations of any kind, people are going to have to figure out how to prevent the impacts of dust from preventing these things from happening. We know that stirring up dust is going to have a negative impact on these incredible lunar heritage sites. So there are two problems here, and they have the same solution. And there's a lot of scientists working on how to stop dust getting in the way of future human activities. Some of the things they've proposed are, obviously, if you're putting your new lunar enterprises in places which are not going to impact anyone else's stuff, using natural terrain barriers like crater rims and mountains to prevent the movement of dust, building blast walls and berms, kind of earth or lunar embankments to limit the movement of dust, stabilising the surface and sintering processes, not using surface transportation to get from place to place or to move materials around, but actually using cable mast systems. In 2011, NASA put together a set of guidelines for managing the impacts to the heritage sites on the moon, for US ones, but they apply to everything. One of their main recommendations was that buffer zones should be created, and they've outlined these for all of the US sites on the moon. So if you are going to be operating near one of these places, you can only approach within certain limits. If you are overflying, you have to use particular angles of approach so that you don't stir up all of that dust. So no one's saying we shouldn't use the scientific data that we can get from visiting these sites, but we do need to have some kind of control over who goes there, how frequently, what methods they use. Otherwise, these places are simply not going to survive, and people 100 years from now won't be able to look at the data. They won't know what Apollo 11 materials looked like in another 100 years, which is extremely valuable information for us. So that's the good news. We can protect the heritage and further our interests in working on the moon by learning how to mitigate impacts from dust. So finally, I want to look at the whole of the moon. So as the moon is a cultural object, that there is no human who has ever been born on the Earth who has not experienced the effects of the moon in some way or other, whether it's light or tides or cultural knowledge or stories. Every person on Earth is a stakeholder in the cultural heritage of the moon. And we ought to remember this, and we ought to be thinking about this. What is the kind of moon we want to pass on to future generations as our human heritage? And I will leave you with that thought as I get to 0 minutes left.
Thank you very much. Okay, and our last speaker is Cara. Can you see the screen from there, or do you want to swap with me? You're all good? Excellent, thank you very much.
So, as an architect, and I work at the Office of the Victorian Government Architect here in Melbourne, I'm coming at this from looking at the lessons we have from how we shape the space we live in now, and then how we can perhaps learn from that. And what we often use in the office is design principles around how you make decisions, around how you shape space. These are ones that we have in our office. They're pretty high level, but it talks to understanding where you are and then responding to that to make places that work for everybody. I'm also a big hippie, and I'm a huge fan of permaculture because it just makes sense, basically. It's nothing new. I love the framework that this has, which is about 3 ethics as well as 12 principles. The ethics are nothing new. If you look at across pretty much all cultures besides the current one we have, they're common to that, which is around respect for the earth, the people, and then a fair share of all that resource there. It's as simple as that, but it gives you a really strong ethos around how you start to make decisions around what you do with the resource you have. The permaculture principles, there's 12 of them that relate on so many different levels to how you actually start working with places. Observe and interact as the first one is also pretty core. Again, it's deceptively simple, but it gives a base, it's that framework for how you do that. And we've talked about how colonisation is something we want to move away from, but I'm going to speak to that a little bit because there's a lot of lessons there that we can learn, and it's even in where we are right now. We'll go back to these if we have time. Because for each of these, there's ways we can then think about how we then approach the moon without going in with solutions of this is what this could look like, of what's here, how do we respond to it, how do we use what we have, and then making design decisions about how to shape that based on that. Here we are on the banks of the river out here, and this is just down the street looking up after English settlers had arrived and started to look at the space they had and then started to overlay their own ideas around how you could use that space. All those tree stumps just in the middle of what is now, that's Market Street down on Flinders, speak a lot to basically ignoring all the permaculture principles, but especially the first one around observe and then interact with what you have and understanding what you have and working with it. And the trees were sort of seen as this resource that you didn't really need, so let's just get rid of that. And the people who lived here had lived here for a very long time and had evolved with the earth, had a really deep understanding of the place, incredibly symbiotic relationship of management and respect where they were pretty much of the land. And that ethos is really quite at odds with the colonial mindset of coming in and sort of going, oh, look at all this resource we have that we can just use for whatever our purpose is, which is also reflected in the way that this grid was laid down by Robert Hoddle, was a surveyor, so in 1837. He laid this very Cartesian, straight, ordered grid over top of what was already quite a well-managed place, literally imposing this order and idea about ownership and spaces and boundaries across a space already had that. And what happened there was that Elizabeth Street was actually a creek. It still is a creek. Laying a street over top of it didn't change that fact. But it's just, for me, it's so symbolic of how you can, it's failing at that observe and interact thing and not responding to the place. And the consequences of that, of just not spending the time to understand the place you are, is that Elizabeth Street floods all the time. There's stories from the first years of people literally being washed down the street, and it's nothing new. It keeps happening because it's still a street and this is still a place where water moves around and all the elements work together. There's someone having a swim down there, this century. And we still haven't learned all these lessons that are just right there in the land, that are all there, that just tell you how to work with it. If you just sort of, I guess, check that colonial mindset enough to not think that you have the answers, and to also not go in going, what can this thing do for me? And what can I take from it, which is that very colonial idea, but to understand inherently the place you're actually going to. The whole question around whether humans should even be on the moon is something we can have a bit of a chat about, but it's quite interesting how we have this tiny little edge of the earth that we've evolved really well to be in, putting delicate human meat bags on the moon away from all of the things that we need, Maslow's hierarchy of needs is shelter and food. Neither of those things are on the moon right now. To get all of that resource there, and then also to work with what you have and understand that, is an incredibly energy dense thing to do. And so it's working, but for me, I see there's a lot of things we can learn from looking back, stepping back and using the design principles to then assess exactly how you start to think more about how you do that. I'd really like to chat more with you guys about that.
Excellent, fantastic. Please thank Cara. Excellent. It's great to have such natural synergy between our talks. Of course, how might we build a base on the moon, whether we should, how we can protect what's currently there, and how we can be sustainable. These are all fantastic things to talk about on an environment panel. So, where are my roving mics? Excellent. So we have one gentleman there, and do we have anyone else? Excellent, fantastic. So while you prepare your questions, I'll give you a second to prepare your wonderful questions. Excellent, good. So we'll start the mic heading in that direction, but just as a very quick one to start, as the prerogative of the chair here, I'm going to ask all four of our speakers to respond your top reason to go to the moon or not go to the moon. Dealer's choice. And whoever wants to talk first can do so.
I have about 30,000, but...
Top one.
Yes. Okay, I'll just say the one that I just made up most recently is I read in some in the papers that an area in Thailand where some movie with Leonardo DiCaprio got made, some beach movie something, got environmentally ruined by tourists going inside the beach with a sunblocks, destroying coral reef, and then, you know, fish went away, then a very rare type of shark went away. Or, you know, the population dropped down. I think it's Thailand or Bali, not sure. If it doesn't have much science in it, I kind of zone out and just read roughly a few things. But then that government of that beach forbidden tourists to go there, and the shark population rise up. And we have this all over. I mean, you probably saw images and videos people put on Bali, how much rubbish is left. You dive through water, and you're actually diving through straws and rubbish that tourists leave behind. So my best reason at the moment, right now, is to basically save Earth from tourists and move them to the moon. But her job is to worry how those tourists won't destroy the moon. And one of my evil ideas, basically, it's like those things where they trick you to go for a lovely holiday, but you actually go and build houses for people. So we'll trick them to go to the moon, and we actually get them to build stuff. So that's my reason at the moment. But I have a few more.
Excellent. Who'd like to go next?
I guess it's an answer for me, not necessarily an answer for mankind, or person kind. As a planetary geologist, I can't think of not going to find out. I just want to know what's there. I just want to see all the rocks. And that may be a simplistic answer, but it doesn't occur to me to think anything else, I don't think.
Curiosity of a scientist.
Yeah.
Excellent. Who wants to go next? Yeah, sure.
I think thinking about this, it's such a great question. I think for me, going back is about the science. And as an archaeologist, I do rocks too. And I want to see those rocks as well, like touch those rocks. So that would be the top reason to go back for me.
The most beautiful rocks I have ever seen were the Apollo thin sections that, as the gift to all the countries of the world, the US gave an Apollo rock and I think some thin sections. I think they come as the set. And in the UK, universities can borrow them. So for 1 week a year, my university would have the Apollo thin section rocks. And every single year and every single student would go through, and every year you would see those rocks, and they were the most beautifully pristine. They were just the most beautiful rocks I've ever seen.
And they're kind of baby Earth, because the surface of the moon is proto-Earth material, so it's a good time capsule.
Yeah.
Okay, you want to weigh in?
I love that. I get the challenge of it and the idea of just going and making our mark everywhere because humans think that they're that special. But for me, it's about places evolve uniquely with what's there, and they just keep evolving. That's, humans are a mere blip, and I love all that we can sort of dream bigger than that, in itself. Beyond that, the realities of it, I think, are really challenging. Yep. But it's about the ethics of how we actually do that, I think, that can kind of start to set that apart, potentially.
Yeah, I'm going to piggyback on that because I think I agree with you. It's not about making a mark, for me. It's about see what are we capable of in a good way, not a bad way. But also, when you look at human history, we haven't changed. We haven't changed at all. From 100,000 years ago, when we became erected monkey, we didn't change. We still fight in the same way. We still have same urges. We just have different weapons and tools to use. And so there's a concept of space as cognitive extension. Because we are the species that are made by the tools we use, if we go to space, and that could be moon, on Mars, our brain will actually start working differently because the tools we're going to use there. Environment is a tool, and we know that because when we study tribes at different geographical regions, we see how they actually reason differently. Anthropologists talk about this quite a bit. So to me, if we really want to evolve beyond our primitive monkey selves of fighting and bickering all the time, space is a good place to do that.
Okay, fantastic. Thank you. So we will ask our first question.
Okay, thank you. Thank you for a very interesting discussion to start us off for today. I'd actually like to make a comment first on what you said, Yasmina, about the place in Thailand. It's actually called, it's an area that's now known only by its Anglo name, which is James Bond Island. And it's called that because it appeared in a particular James Bond film, and that's what brought all the tourists to it and actually caused all that environmental problems. But I'd also like to make a comment. I love the fact that you used Tasmin Archer's sleeping satellite. But actually, she's not American. She's a black British woman.
Oops, sorry.
And no, but I think it's even more interesting because she's coming at it.
Her accent in the song is very American, so I just assume.
Yeah, no, she made it more commercial by. But I actually had the great pleasure of meeting her on one occasion, and she was, she's actually, say, British. But I think that makes it more interesting because she's not, talking even from, her own culture in the sense of being an American and saying, you sold us out or why didn't things happen. She's also talking from someone in another part of the world saying, why didn't this happen? In other words, it's representing that global effect or reach of the moon landings. And leading on from that, we've had a couple of comments about that image of Apollo 8 looking at the Earth and how that created, or didn't create, but was a great stimulus to the environmental movement. But I'd like you all to comment on this, that before the Apollo 8 image, there was another image of the Earth that was taken by one of the Lunar Orbiter spacecraft. So this is a robotic spacecraft, and it took a picture of the Earth, and that was the very first, but it was only black and white. Now, do we somehow contextualise our environment when we see it in colour, but not in black and white? Is there something about that image that couldn't grab us in the way that those colour images from Apollo could? So I think that's part of, that broader cultural context of the moon. So sorry for that being a bit long-winded, but I thought there were a couple of interesting things to touch on there.
Oh, that's great. So as an astronomer, I can kind of explain why we use colors so much. Often when you see images now, they're colored. Obviously, camera sees them black and white, they're just pixels. But then those who process the image decide to color them a certain way. And for astronomers, color has a meaning. It conveys information. So, whether you want to show that something is hot and cold, whether you want to show that something is dark, that it's kind of dug out or light. So there's a color as a way of communication. But my personal opinion is why the picture taken by human versus taken by robot was more impactful, because it followed by words of a human. And so the astronauts themselves have provided those words of the impact of them seeing that. If we had more developed robots then, they would have made some cool Twitter handles, and we would have treated the way we treat curiosity now as almost as a person. If that was available then, I think it would have been impactful as well. But I think we, as humans, and this is what art shows all the time, we have feelings, and we respond to feelings. So if a picture sits there, we kind of go, okay. But if a human said, wow, this is amazing. Look at that thin atmosphere sitting there. It's only that thin. We need to preserve this. I think that's much more powerful. That's my opinion.
I think that's so interesting. And yes, imagining what Twitter might have done for that interaction back then. But I think with that Lunar, and there was the AST photo as well, wasn't there? It's like we're learning to see our... this is like, these are views that people had speculated about and written about, but then we're learning a visual language of space we didn't have before, of seeing ourselves from the outside. And I think you're right, the colour makes an impact, as well as the idea that a person has taken this. But I think about this sometimes too, like classical Greek and Roman sculpture, which we see as that sort of beautiful, creamy white marble, so aesthetically pleasing and pure. And archaeologists know these statues are actually painted in incredibly garish colours that, to our sense of it, we think of that sort of classical aesthetic. And the colour has been stripped out of those and given us a sort of false impression of this culture, I suppose. So it's kind of a reverse thing. Or is it the same thing? Those early photos were the stark grey tone kind of thing, which people are responding to less. It is kind of in reverse. And then you put the colour in. Because it's also the same time, colour photography isn't... for people on Earth, you don't have colour cameras. I mean, this stuff was all there, but it's not... everything's not colour. People are watching black and white television, taking black and white photos. That whole... colour vocabulary sort of isn't quite there yet, although it's around. So I'm not quite sure I'm going with the classical statue colour metaphor, but I think there's something there about how we perceive things and how things appear in black and white as well.
And possibly to reinforce that a little bit, maybe, I'm not sure if it will or not, we'll see. In planetary geology, colour, as we've said, colour means something, same as in astronomy, and it can completely alter your perspective of the geological landform. So in the really early black and white photos, I remember the professor who ran the group that I was in doing my PhD, he was the world expert in the eruptions of Mount Etna. And so when the first photos of the moon were taken, he had a mate in America who rang him up, who was helping NASA, and he said they can't tell if they're volcanoes or impact craters on the moon. They've got all these round things. Can you come and have a look? So they flew him over. He took one look at them and said, it's not a volcano. And then he showed them how to take, and then they started taking stereo images. And then they started to see the relief, and they started to see the different bits of how the images were in context, and it all fit into place. But until he sort of came over and said, no, look at it this way, they didn't see it at all. So I think there's something there as well, maybe.
Dad?
My first response was similar to Alice's in that at that time, it's all within the context of how people would have watched a black and white film but still overlaid their own experience of how that actually is for them in colour over that. But then the blue of that other famous image that I showed before has another layer of how you just understand where you are and how that can start to then place you in the broader context of how you think about everything else.
It was interesting when Helen has her formation of the moon slide. I don't know if you noticed, but Earth was like it is today, but that was proto-Earth, so it didn't have clouds and continents and stuff. But if you had to show a picture like that of proto-Earth, people would think it's Mars or something like that. So you almost sometimes have to put inaccuracies so that you don't build misconceptions, but then you have to just emphasize that that's not how Earth was then. So it's tricky to be able to convey some of these information if you want to be scientifically completely correct, it's almost impossible to convey it just with a picture.
And in fact, quite a lot of the images for that slide that I found, as well as having Earth looking like Earth in that first picture, they had the impactor looking like Mars, because everyone describes it as a Mars-sized object. And I'm like, I almost didn't say when I was talking earlier Mars-sized object, because I've had people ask me, oh, Mars hit the Earth? No.
Another example I just remembered is when I show students for the first time the sun with a, just continuum. And they're all excited, they're going to see the sun, and they go, I can't see the sun, there's this giant orange ball in a way. And I said, that's the sun. But they go, but where's all the fire and all the thing? I said, well, we have to put different filter to see this. This is just continuum. It's just orange ball, and if you're lucky, we see some sunspots. So it's again, the daily feeling of the sun is a giant fireball that's burning, and they want to see something burning, but they just see this flat orange disc. So once you work in a particular field, some of those things become natural to you, but it's always like seeing from other people's eye for the first time. You remember how actually it's not very intuitive. So.
Well, the sun feels like it's burning us today.
Yes.
And I just wanted to add to Kara's brilliant point about how we place ourselves, and the colour blue is so important to that. So we've got our water in our sky, and we do see ourselves as living on a very blue planet. So the whole pale blue dot, the fragility of our planet, and when you see it from that scale, is something that astronauts have described being very profound, that experience, that overview effect. Now, I hear the mic is over here somewhere. Excellent. Thank you.
Good morning, everyone. I just have a question for Alice about archaeology. Just as with the Nazca lines in Peru, to use an example, the public can't traipse all over them, but researchers can investigate them. Do you foresee that, say they put in buffer and exclusion zones on the moon, that the public won't be able to traipse through there, but researchers will get special permission to go and visit these sites?
Yeah, I think the sort of logical way to go about this would be to have some kind of permitting system. So if you're a researcher, you would have to lay out your reasons for wanting to go there. Are you going to take samples? What information will we get from them? How are you going to share that information? What benefits will there be? And the public thing is a different one, because these are, if we're going to make an argument that this is sort of world heritage or outstanding universal value, then the public has a right to engage with these spaces, but then we're looking at them being completely destroyed in the process. So I think a good example is the site of Lascaux, which is a 15,000-year-old rock art site in southern France, northern Spain, which basically, when it was discovered in the 70s, had a high rate of visitation such that the artwork began to, people probably know these images, it's like sort of mammoths and bisons and hares, all this beautiful Ice Age rock art. So they began to deteriorate. So they've created a 3D replica, which you can go and see. So scientists can still go in there, but the public goes to see the 3D replica. And this is a question of authenticity. Because the reason space-flown objects have high market value is the guarantee that they have been in space. So people value that somehow. But if they don't know that what they're seeing is not the real thing, they don't care, studies have shown. So Lascaux is very successful. I think something like that for the lunar heritage sites might be possible as well. So people can still have an experience and engage with it in a way that's going to have low impact on their survival. Because I see a point, 500 years from now, somebody's saying it would be so fantastic if we could go and get this data from the Apollo 11 site. say, well, that's too bad. Like 10 years after humans went back to the moon, that stuff was gone. So I think we're kind of looking at planning ahead for the future in that way, but not so that it excludes legitimate study that can actually assist us in future off-Earth enterprises, I guess, yeah.
You can imagine as aquarium, as you go, you can't touch the fish, but you can see it. So we can make like space museum.
It might be telepresence as well. So NASA is working on lunar drones. So, you know, it might be possible you go to the moon, you VR yourself up into a little thing and you use that to zip around these places with low impact. So lots of possibilities, I think.
Excellent. Next question.
I also have a question about archaeological heritage. It takes an awful lot of money to move a kilogram of matter from the Earth to the moon. And it may be that some of these heritage sites have materials that could be used in the development of space structures elsewhere. So there is a competition between what might be practical salvage and archaeological heritage. Would you comment on that?
My comment on that would be, I suspect a lot of those materials are going to be in extremely poor condition because they have been exposed to all of those environmental factors. I think that is a possibility, though, because it does cost a lot to get things up there. The same applies for space junk in Earth orbit. Where that cost to get it up there, it would not make sense not to use that as a resource. But I would say that if I would see something like that happening in like an extreme disaster situation, let's say. So some astronauts are in a situation where they are, I don't know, in danger or separated or unable to get back to the base or whatever. They need to use what resources are around them to survive. So I think people would see cannibalising these sites in that circumstance as kind of okay. But if your lunar mission depends on you using those materials, you haven't planned it very well, I would say.
Is that, it's all still about putting humans as some kind of pinnacle of everything and then relating everything back to, or the humans touched that 50 years ago, therefore that is more special now. And I'm not like saying bar humbug to that, I'm just saying it's this incredibly quite...
I think this is not just a question of humans have done this, it's more about that material has been sitting there, it has been exposed to solar radiation, exposed to different things. So we can actually study how material that we build rover reacts to solar radiation. So it's actually informing us to how we build. I mean, similar way we study Egyptian pyramids to figure out how they, you know, the secrets of architecture. Some of these things actually then inform future. So they improve material that you want to build. Because if you in a lab bombard something and then it actually goes in space, it's different because we can never create vacuum on Earth. So we can build the closest possible environment, but it will never be like space. So Moon is actually a giant lab for us, but it's also about materials. So if we think, oh, on Earth, this material has sustained so much radiation pressure, and then on the Moon we find out, oh no, this is way off, because we still had, you know, earthly gravity and earthly pressure, and sometimes you don't realize how many of these things are. So I don't think people treat this so much about, oh, it's humans have been there and therefore it's precious. I think it's, as a researchers, people will go into saying, okay, what have happened to this 20 years after? What have happened to this 30 years after? More in that kind of, sort of more technological understanding. But then, of course, there's a cultural idea of you wanting to preserve.
I think Kara's rightly identified that heritage centres humans. And there's been some interesting work done on robotic heritage. I mean, in the sense of, can a robot develop, or, you know, we're going to have more and more AI kinds of robots out there. So how do we take their interests into account when we look at this stuff as well? And I think there's a lot of Well, increasingly philosophies are saying we need to decenter humans from this whole enterprise. And I have a lot of sympathy, I guess, with what they call the cosmic preservation. It's not exactly a movement, cosmic preservation philosophy, I guess. But from my perspective as a heritage person, I think it's that social significance which is important. So if people feel strongly about things, the scientific stuff, not the scientific rationales, but the scientific potentials are maybe less important. It is, and sure, you're right, that is totally centering how humans feel about this. And there are other perspectives you can take as well. But I guess I'm coming from that perspective as a heritage person. And I also think that this is one of the things that can connect people to the moon and draw them into a dialogue where decisions are not going to be made by engineers and politicians and private corporations, because those connections we make with these places are our legitimacy to say that we have a say in this, we have a stake in this as stakeholders, and it is not for massive private corporations to remove that in the direction that we're seeing currently. So I suppose I can see an intersection there, but I absolutely take your point. It's inevitably we are centering humans in a way that is what's happening now, but maybe in a longer term is not a useful way to approach the solar system as a whole.
Or in fact, the environment of our current planet, of course. Okay, we have time for one more question, so where are we? Do we already have the mic there?
You've shown how when Europeans came to Melbourne, they changed the environment, chopped down all the trees and so on. People in Europe would not have been able to see that because it's around the other side of the Earth. If mining takes place on the moon and large-scale changes to the albedo is made by stirring up the regolith, people from Earth will be able to see that. Do you think that that will engender some protest from the people on Earth that the albedo of the moon is being changed?
I guess that comes back to the value that's placed on what's there and then what the change means. And whether, so that changing the landscape here was seen as a progress that was worthwhile because it meant settlement was possible for one group of people. And the loss of a lot of other things wasn't considered as important as that. So
you would have to cover a huge surface of the moon with darker color to change albedo. So whatever you build on the moon would have to be light color, because you don't want to absorb more sunlight. So I don't think anything that is planned to be built or mined could actually change albedo that much. So we will still have beautiful full moon and it's not practical, because if we do that, that's going to be more energy inefficient than blending in with the environment.
But I think this is really interesting because, yes, we're not going to necessarily see new dark patches appear on the moon, but there are people watching the moon. Like, there's an incredibly strong amateur astronomy photography community around the world. They're photographing the moon all the time. So, and I actually think this is, so we will see, and they post their pictures on social media, and some of them are incredibly talented photographers, so they're going to be making available to us pictures of what people are doing on the moon that we can see. And I think that's great, because that's a way of us actually monitoring that whoever's operating on the moon is abiding by whatever conditions are set at the time. And I have a vision of having a community satellite, maybe crowd-funded like some lunar missions are, that will be for the people of the Earth to be able to monitor all industrial and human activities on the moon. So we're not reliant on them conveying this information to us. Private corporations, for example, are not accountable to the public. So they don't have to tell us what they're doing there, but if we can see that, we have a way through that amateur photography community, maybe through a citizen satellite, we can have a way of calling people to account for whatever they do to that environment. So I think there's lots of interesting potential for people to get involved at this level and analysing that data as well. So, yeah, I mean, because this is going to change the moon we think we know, even if we can't see it, I reckon.
Okay, I'm going to cut that off because we have time for one more question. So I'm going to ask the lady just there, just behind you, who had her hand up before, and we'll finish on your question. Thank you.
Thank you. I wanted to ask, does environmental ethics extend beyond life and biology? Because as far as we know, there's not life on the moon. So should we care about approaching sort of lifeless rocks sensitively? Which kind of touches on what Jasmina said about sending all of the tourists to the moon. And can we assume terra nullius on the moon? It's a bit of a loaded term, but kind of relevant in terms of it being void of occupation and life.
Who wants to start with this one?
That's actually a question for you as space scientist.
Okay. Well, I didn't plant this question in the audience, let me stress. However, my interest in space ethics, of course, includes questions like, does the moon have any rights? We want to go to the moon, but what do we have to offer the moon in exchange for that? So do we have obligations not to mine in an unsustainable manner? And if so, are those obligations to other people on our planet because of that connection that we have with the moon? Or is it because the moon itself has some inherent right to exist and to be preserved in a particular way? So the preservation of the lunar landscape, of course, also things like how do we guarantee that it's still available for future generations? We all do share that connection with the moon. Want to follow up with any other points?
I just want to say, for me, it's but being environmentally mindful is not about that place itself necessarily, but about who we want to be. But space, by default, will have to be environmentally friendly because we cannot be, we can't make, the resources will be scarce, and we have to recycle everything. We have to carefully reuse everything. We have to think before we act, because if we drill for 5 days somewhere and it's waste of time and energy, we might die in the next 5 days. So that's one reason I like space exploration so much, and building space bases, even if they're not permanent, even if you just go and do scientific exploration or just tourist run, to see how you can, to imagine how well you can live. We are so disrespectful of how we treat Earth. I mean, just daily, just looking around, as older I get, I just want to go, slapping everybody in the head, saying, do you know what consequences of you just dropping that there on the floor? Some fish will die, in 10 years because of that. So, I mean, so I'm at the generation that was born into, let's use whatever, to now, going, no, I know consequences of this. The beads that we use in exfoliators are now, killing fish and changing. So everything is a system. It's a dynamical system. But because we don't see it on our daily life, we get we see polar bears starving for one day and we feel horrible, and then we forget about it because the next Netflix show is out and we have to watch it. But if you experience living in space for a week, I mean, we have Mars analog stations where people go for 2 weeks and they come reborn. And if we can send everybody, one of the astronauts said, every politician should be launched in space to see what Earth means. They will change their way, how they treat Earth and how they make policies. So this is where I think the power of space is. And as I said, by default, you would have to be environmentally savvy anywhere you go, because you just can't afford to lose any material.
Okay, very quickly, final comments from anyone else?
I think you're spot on with the terra nullius comparison. And I'm a huge fan of the work of the radical feminist eco-philosopher Val Plumwood, who conceives of environments as sort of agents in their own right, but also sort of co-dependent collaborators. And I think that's a really useful way of conceiving how we might go forward in our interaction with space environments.
Anything to add? Not mandatory? Okay, please join me in thanking our panel.
Thanks Environment Panel, that was really fantastic. We'll have a break now, so a small break. We'll be back at 12:10, so feel free to go get a coffee or have a relax and digest some fantastic points from all the speakers there. And look forward to more questions.